Hello and welcome to my webinar, Building WebSocket Browser Applications with Spring Framework 4.0. Today we'll be focusing on how to build such applications using a new capability in browsers based on the WebSocket protocol. We have a lot of information to cover, and this is a very broad subject. I will be taking questions at the end of this session. And in the meantime, you can post your questions, but we may not be able to get to the majority of them until the end of this webinar. We're going to start by talking through the subject, and then we will do a demo. We'll take a look at a sample application. And at the end of the webinar, I will also present a few links, including reference to this very presentation so that you can browse it online after the session is over. Let's jump right in. One major difference that we have since 1 year ago, since last year, is now in Java land we have an actual API for using WebSockets in an application. This is the JSR 356. It was done as a collaboration of servlet containers. Many of them have pre-existing implementations, including Tomcat 7 has pre-existing WebSocket implementation, Jetty 7 and 8, as well as Glassfish have all pre-existing implementations. And that, of course, resulted in a lot of debate on the JSR expert group since the initial versions, the existing implementations, to a large degree were essentially experimentation with WebSockets for a while until finally we arrive at something which is being discussed and debated across. And as a result, all the WebSocket engines in those servlet containers have actually been rewritten completely. That means a couple of things. Number one, now is a good time to start actually thinking about using WebSocket technology in your applications. And two, it means that we have a convergence of runtime implementations that will share a lot of commonalities and we'll share a lot of common approaches and understanding of what it is that needs to be exposed as a result of this new capability called WebSocket. So all of that is great. And in terms of specific versions, we have Tomcat 8, which is currently RC3, actually. The slide needs to be updated. It's currently RC3. And the news here, the other important bit regarding Tomcat is that this is going to be backported very soon to Tomcat 7. So if anybody is using Tomcat 7 WebSockets, that will be replaced by what's in Tomcat 8 that's based on JSR 356. Jetty 9, which is also a complete rewrite of the Jetty 7 and 8 WebSocket runtime, has a native WebSocket API, which is then layered on top with a JSR 356 API layer, and that's going to be available in Jetty 9.1, which just came out with a release candidate yesterday. And of course, we have Glassfish, Glassfish 4 with the Tires WebSocket engine, which is also used as the reference implementation for the JSR. And other servlet containers that did not have previously WebSocket support are also going to follow now that we have JSR 356. So that's really the big story around JSR 356 is kind of the push to make this available in all the different runtimes that you may be using in your application. So rather than going into the details of the JSR 356 API and explaining a lot about the mechanics of the API, we are going to dive right into the heart of the matter and explain why JSR 356 alone is not sufficient. First of all, the scope of the JSR does not include fallback options. The JSR, rightfully so, is very much primarily focused on supporting the WebSocket protocol. And there is really a lot that needed to be debated, and there was a lot that needed to be discussed and decided within that particular scope. However, when running an application, public-facing internet web application, a key concern is going to be the availability of WebSocket support in browsers. In particular, Internet Explorer, less than version 10, does not include support for WebSocket, which means that you're going to need some kind of a strategy, fallback, they're known as fallback options, to use in case it's not available there. There are also potential network proxy issues with the use of WebSockets because the proxies may be too restrictive, or they may not be configured in a way that would allow WebSocket connections to begin, or after they start, proxies may also discontinue such connections because they don't think that they're regular HTTP traffic. So both of these mean that there will be plenty of cases in which you need some kind of fallback options to still support users with this new API. Second of all, the JSR is really not focused on sub-protocol support. Again, rightfully so. This is a very large topic altogether, the subject of browser-based WebSocket applications. And if you consider how we build web applications today, we're not down on the level of using a socket. We're using HTTP, which is a higher level application protocol that gives us a lot of capabilities on top of a TCP socket. And just the same, JSON, the WebSocket protocol, the Internet WebSocket protocol, has provisions for using sub-protocol, which is the keyword for a higher level protocol or an application level protocol that can be used on top of a WebSocket, just like we have HTTP on top of TCP sockets. And without such a sub-protocol, it is really difficult to build real applications, and that is going to be a major focus of today's webinar. So we'll be explaining that in a lot more detail. In JSR 356, also, there's no way to handle both HTTP and WebSocket requests from a single place. This is known as the front controller pattern, and pretty much everyone will be probably familiar with that concept from using web frameworks like Spring MVC, which has a dispatcher servlet that essentially serves as the main entry point for every incoming request. And then provides a variety of facilities. You can configure a number of controllers to delegate incoming requests to. Now, it would be ideal if we could use a single servlet for handling both HTTP and WebSocket requests, but that's not possible, unfortunately, with JSR 356 alone. And once you have the reference to this presentation, you will be able to click on these links and follow through for more information. So the bottom line is that between fallback options and sub-protocol support, essentially JSR 356 fundamentally, WebSocket API is too low level for an application, for most applications. And either you need some sort of a framework on top of it in order to make it usable to applications, or if you don't use a framework, because you will need a certain amount of infrastructure to solve the kinds of issues that every application will need to solve, you will basically end up most likely building your own framework if you don't use one. Either way, the point is that there's a lot of infrastructure to deal with. So let's take a look at that in more detail. Why is a WebSocket API on a very, very low level? So WebSocket is a very cool new capability indeed. However, if you consider a single physical WebSocket connection per client, which is really what we should aim for, we shouldn't use the number of physical connections as a way to organize our application functionality. Essentially, in JSR 356, that translates into a single annotated class, a single @server endpoint. In effect, that means that when you have a single physical WebSocket connection from a browser, you will have to handle all incoming messages from a single annotated class. And if you're coming from a background of using a web framework with annotations like Spring MVC or be it JAX-RS or some other web framework, you're used to having a variety of controllers with request mapping methods, and you can organize your logic however necessary according to the logic of your application. You're not limited to using a single class. In essence, the WebSocket API is really not the right level of abstraction for applications. And I can make an analogy there to servlet. When we build web applications today, we don't write a servlet to implement the application. We use a web framework that in turn implements a servlet, like the dispatcher servlet in Spring MVC, which then in turn gives you higher level capabilities, map requests to through request mapping methods, and you can have any number of controllers as necessary. And I think that analogy works here pretty well. If you're working with WebSockets, it's a little bit like implementing a servlet and trying to have your entire application functionality driven through that one servlet. Also, when you consider what the WebSocket protocol provides, the raw WebSocket communication, the messages, the WebSocket messages are really just a very thin level above raw TCP streams. A TCP stream is just a stream of bytes, whereas a WebSocket message, the WebSocket protocol adds boundaries around messages. So this is really all that you get. You get a stream of messages, and what is in a message is entirely up to you. A message is in effect a blank page, and you can write anything. You can have a JSON content in it. You can have anything else you want, but somehow you have to express what this message means. Who is it for? How should it be processed? And eventually that leads down the path of using some kind of a custom format. And because both client and server need to understand what this format is, you can see the kind of awkward decisions that you have to make that may, in the future, kind of prove to be difficult to deal with. Also, when we have a blank message, it is very difficult for a framework to provide any kind of meaningful annotations. Yes, JSR 356 provides annotations. You can write an annotated endpoint, but once again, you're limited to a single class, and that's not really the fault of JSR 356. It really comes down to the fact that the WebSocket message is a blank page, and there's really nothing more that you can do to build a rich programming model until you decide what is in the message, what kind of format are we going to use. So to put this differently, what is the equivalent of the request mapping annotation that we have in Spring MVC? Of course, there we're using HTTP, so we have HTTP methods, we have URLs, we have query parameters, headers, all kinds of things that we can use to delegate requests, but with WebSocket messages, we have none of that. When we have messaging going back and forth, we are going to have to deal with some way to have subscriptions. This is a publish-subscribe pattern that we want to be able to implement. Server should be able to broadcast to a subset of users, and all of that is really something you're going to have to build. There are no guarantees for message delivery in the WebSocket protocol. Even though a message may look like it went out successfully, you really don't know if it was received and processed by the client. Once again, all of these are higher level concerns of the protocol, of an application level protocol, potentially. This is why using JSR 356 alone is really not sufficient. and you will end up having to resolve all of these questions and essentially building a framework of your own if you don't use one. With that in mind, we can now turn to Spring Framework 4 and take a look at the feature set that's available. First of all, we provide transparent WebSocket emulation based on the Soc-gs protocol. What this means is that you can write to a WebSocket API, an application to WebSocket API today, and if WebSocket does not happen to be supported in an environment in which you're running, for example, in Internet Explorer 8 or 9 or 7, then we're going to, the application is going to automatically fall back to HTTP-based transports that Soc-gs protocol supports, including HTTP streaming or HTTP long polling, etc. But all of that is transparent. In other words, the application does not need to do anything different. We have a set of abstractions for building messaging architectures, things like representations for a message channel for passing messages, a message handler. This is a subset of types that have been brought over from Spring Integration. A lot of you, some of you may be familiar with Spring Integration. Essentially, we recognized that when you work with WebSockets, that is pointing towards an event-driven messaging application. And we've already been doing that sort of thing in Spring Integration for a long time. And a subset of that functionality that relates to core messaging concerns has been moved into a new Spring messaging module in the core Spring framework, a sort of Spring Integration Lite, if you will, to enable building these kinds of applications. Of course, Spring Integration continues to exist, and in its next version, it's going to actually depend on these types, but it solves an additional set of problems for enterprise integration design patterns. What we have here is just core messaging abstractions. We also have Stumpf subprotocol support. This is going to be a major subject of this presentation, so we'll get back to that. Effectively, what we aim to provide is a foundation and a programming model for going beyond hello WebSocket world type applications. Just a couple of words on Soc-gs. Soc-gs aims to emulate the WebSocket API as close as possible. However, recognizing that today you need some kind of fallback options, it aims to have at least one streaming protocol per major browser, meaning that if we have to fall back from WebSocket, perhaps we can fall back to HTTP streaming that allows us to be as efficient as with the WebSocket itself. And there is cross-domain and cookie support. And if that's not available, then falling back to polling, which should work pretty much in any environment. So that's really what Soc-gs is about. It's about ensuring that your WebSocket style application is going to work in any environment. And if it has to be less efficient in some cases, then that's what it takes to run the application. But it means that you can start working on these applications today. Soc-gs does not have a Flash-based fallback mechanism. Now, Soc-gs and WebSocket are both very interesting topics on their own, and we can spend this whole presentation simply looking into that. However, what this presentation is about is the higher level, application level programming model. And as you will find out, once you begin to think in terms of messaging patterns, in terms of an application level protocol, you don't tend to think about the WebSocket API or the WebSocket level as much. Now, just like when we write an HTTP-based web application, we don't think about sockets and we don't think about sending messages. Well, at least not in terms of the programming model. Just the same here, Soc-gs and WebSocket, the transport layer concerns, which are there. That's what the application runs on, but it isn't what we actually deal with in the application to implement our functionality. So with that in mind, I'm going to now start explaining a little bit about the Stumpf protocol, just a very quick overview. What is Stumpf? Stumpf is a simple messaging protocol for the exchange of messages, supports basic message patterns. It was originally created for scripting languages like Ruby and Python to allow them to connect to enterprise message brokers. It has a very wide support by message brokers like RabbitMQ and ActiveMQ. Pretty much any message broker out there, enterprise message broker, is going to have support for Stumpf. And it makes it suitable for use on the web because of that simplicity and because of the way that it basically looks at messaging in a way that makes it accessible to scripted clients or web clients. The protocol itself is based on frames. It assumes running on a stateful connection like TCP, sending messages one after another. It can run over WebSocket as well. Of course, WebSocket is not much more than a stream of messages on a TCP connection. And the frames are modeled on the HTTP protocol, so they should look familiar. Here's an example of the content of a Stumpf frame. On the first line, followed by a new line character, we have a command that expresses what this message is about. Then we have one or more header value pairs on separate lines. And then we have two new lines and an optional body that can carry further information. So as you can see, this is very reminiscent of HTTP messages and should feel familiar to pretty much every web developer. So some example of commands when we are sending messages from a client to a server. First of all, the send command is for clients that want to produce messages. The subscribe command is for clients when clients wish to subscribe to specific types of messages. There's also a unsubscribe as well. For server messages to clients, we have a message command, which is the equivalent of sending a message from the server to the client. We have an error frame, error command, which the server can use to send an error to the client. And then we have receipt, ACK, and NACK that can be used to confirm messages, the receipt of messages, or acknowledging that messages have been received from server to client. Now, a central concept in Stumpf messages is the destination header. So when I send a message or when I subscribe, I'm going to provide a destination header. And the destination expresses what it is that I'm subscribing to, or what the message that I'm sending is about, or who is it for. The destination itself is an opaque string, meaning that it can be anything. There's no specified syntax for what it should contain. But as you will see, very often the various message brokers have some commonality in the kinds of destination semantics that they support. But ultimately, it's left to the server, and servers can add as little or as much, put as little or as much meaning as they want to. To give you a more specific idea, a typical destination would look like a URI path, something like /q/a or /topic/a, allowing us to express different kind of message semantics, message patterns. And message brokers actually define the semantics, so that's something that you can check to see what the message broker supports. This is an example of a client producing a message. We're sending a message to a destination of /q/trade. In effect, we are sending here a trade request. We are trying to buy shares of EMC. And you can see that the content type is application JSON. This is very similar to an HTTP request being sent to the server, except in this case we have a Stumpf message being sent to the server. Now, when the client wants to consume messages as opposed to produce messages, it needs to subscribe. The server is actually not able to send anything to the client unless it is in response to some kind of a subscription. So step number one, the client needs to send a subscribe message. And you can see here the destination expresses what it is that we're subscribing to, in this case, stock quotes. You can see the wildcard in there. Again, the semantics for destinations are going to depend on the server message broker. And very importantly, we have an ID for the subscription so that when the server sends a message back to the client, you can see the subscription ID matches. So that's how the client knows which subscription this is in response to. And that means that the client can organize its processing around the various subscriptions. That's a very nice capability to have. So what do we get of using Stumpf as opposed to raw WebSocket? We actually gain quite a bit in doing very little. Number one, we get a standard message format. Now the content of our messages is using a protocol that is a standard protocol, which is used in messaging, and it has very wide support both on the client and the server side. On the client side, we have libraries such as Stumpf.js that you can start using today and use them to send messages, and they're used in a variety of other server, in combination with other server runtimes, not only in Java, which means that you really get the benefit of that kind of wide support. We get common support for common messaging patterns. We don't have to reinvent the wheel here. We basically follow something that's been done for some time, and we can do things intelligently when we build WebSocket-style architectures, sort of building on the shoulder of giants. And we get the ability to incorporate a full-featured message broker in the backend. In other words, when we use Stumpf, we have the choice to plug in something like Rabbit or ActiveMQ for the actual delivery of messages in the backend. And I'm going to explain this in more detail later, so there's going to be more on that. But as you can see, simply by deciding to use Stumpf, we already have a standard message format, and we have client-side support, and we didn't have to write a line of code. So all of that is really a big gain. Next, we're going to talk about Stumpf support in the Spring framework itself. We have a new module called Spring Messaging, which contains the Stumpf support. The Spring framework now understands the Stumpf protocol and can process Stumpf messages. And we have a number of message handling annotations that serve as the programming model, just like we have the request mapping annotations in Spring MVC. Here we have annotations for processing WebSocket messages. We have some key abstractions that have been moved from Spring integration that I mentioned earlier, things like message and message channel. These are going to be key in terms of building an event-driven architecture. Is really what we need when we're dealing with any kind of messaging scenarios, in this case, WebSocket messages. It's basically intended to be the foundation for WebSocket-style messaging architecture. So without any more explanation, let's take a look at some examples. Here we see an annotated message handling method. It's a class annotated with the controller annotation. That's the same controller annotation that we use in Spring MVC. And yes, in case you're wondering, you can have request mapping methods in this class as well. So here we see a message mapping annotation that is going to process Stumpf messages from the client that are for the destination of /greeting. Now, the argument into the method, the greeting string, is going to come from the body of the message. This is, again, going to feel very familiar to Spring MVC, just like we have a request body annotation there. Here we have the ability to extract the body of the message, the payload of the message, and pass it into the method. And the application can process this however it sees fit, but if you think about it, if one client sends a greeting, we probably want to do something with that greeting. We want to enrich the message and then pass it along to every subscribed client. And in order to do that, we can add a timestamp in this particular example, and then we're going to return that from the method and use the send to annotation to send it to the message broker. And that's going to be a destination of /topic/greetings. So you can begin to see that we use prefixes as a way of deciding where messages are going. Is it going to go to the application to do some processing, or is it going to go to the message broker in order to propagate the message to all subscribers? In this case, what we're doing is we're having the application process the message first, and then turn around and send it to every subscribed client after having added the timestamp. So what actually handles /topic/greetings? What is this going to be handled by? Well, we provide a simple built-in message Stumpf broker, which can take these messages, keep track of subscriptions, or you can use a full-featured external Stumpf broker. And when I say external, that could mean an external process in the case of Rabbit, which of course is built on Erlang, so it's running outside the JVM. Or it can be ActiveMQ, which can run even in the same process as your application. Either way, we'll come back to this in a moment. The point is that when you send something to /topic/greeting, it's going to go to the message broker and be delivered to subscribed clients. What we're looking at on this slide is how to configure all this. As you can see, it's actually pretty easy to enable the Stumpf support, Stumpf over WebSocket support in Spring Framework 4. All we have to do is use the enable WebSocket message broker annotation, and then there's an interface that we can implement in order to customize it. And the two things that we're going to want to do are, number one, we want to configure what's the prefix for our Stumpf endpoint. In other words, when we create a WebSocket connection or a soc-gs connection from the browser, to what URL is it going to be created? So in this case, we're using /Stumpf, which means that we can open a WebSocket connection to /Stumpf and then begin to exchange messages on that. The second thing that we want to do is we want to configure the message broker that we want to use. And we're going to start out with using the simple broker. So it's quite easy to enable at a particular prefix. And as I will mention later, the simple broker is really something that we want to use only to get started. Maybe it's okay for some small applications, but for a more advanced applications and for good scalability, we're always going to recommend using a full-featured external message broker. Also, we're going to configure the prefix for annotated methods. So destinations that begin with /app are going to be delegated to annotated methods. And that prefix is going to be removed before the message is matched to annotated methods. To give you an idea of the sort of actual infrastructure behind this, the actual components, here's a message flow diagram. On the left, you can see incoming and outgoing WebSocket messages. These are Stumpf over WebSocket messages, meaning that we have a WebSocket message whose content is a Stumpf message. And at the top, you can see the messages being sent from browsers, from clients to destinations such as /app or /topic, which are then placed on a message channel. And message channel is really just something that passes the message from one side to the other, possibly using asynchronous handoff. And on the other side, we have a controller, a message handler for annotated methods, delegating to annotated methods with, for example, add message mapping. Or we have the simple broker. And as you can see, the annotated methods themselves can further send messages to the message broker. So that gives you kind of the full picture of the capabilities here. A message can come from the browser. It can go to an annotated method. then the annotated method can do some work, maybe save something to the database, maybe do some other things, and then in turn send a message to the broker, which will then be broadcast to every subscribed client. Now, we can also send messages from anywhere. I think a lot of you are probably going to like this example because it really shows how the HTTP web applications that we know can connect to the messaging side of things, to the WebSocket side of things. What you see here is an example of a Spring MVC controller, which is injected with a messaging template. In case you wonder, that SIMP prefix stands for Simple Messaging Protocol. For example, Stumpf is one example of that. And then the method in this controller is a regular Spring MVC controller method. It's a request mapping for HTTP post with to URL of greeting, which means that we can have a REST API accepting greetings, and then those are going to be enriched with a timestamp, and then we can use the messaging template to send a message to the message broker. That means that we can use a Spring MVC controller to broadcast messages to connected clients as well. And of course, the point here is that we can do that from any application component, not just a Spring MVC controller. Another example of something common to do is the ability to do the request reply pattern. So we have asynchronous communication here. We can send messages from the browser to the server, and the server can send messages back, but it's not necessarily request reply like in HTTP. However, when we are loading the UI of a web application, we may want to initially have a request reply exchange in order to present some information on the page. We want to load the application. And certainly we can use HTTP for that. I mean, we can still do the simple thing and just send an AJAX request and load the UI in this way. That's absolutely a choice. But here we're just demonstrating how to do it entirely using messaging. So in this case, we're going to, the client is going to subscribe to destination of /positions, and then the server controller is going to map itself to that and respond with a bunch of portfolio positions that the client can then use to load the UI. And in case you're wondering what the principle is, where it's coming from, I'm going to come back to that in a little bit. But suffice to say, this is based on HTTP authentication using Spring Security. The next subject is how to plug in an external message broker. Why would we use a full-featured broker, first of all? Well, the simple broker supports only a subset of Stumpf, including subscribing, unsubscribing, and sending messages, which is great for getting started, but it doesn't support acknowledging messages. It doesn't support sending receipts. So it's really just intended to be a simple getting started stepping stone. It also relies on a simple message sending loop, which means that whenever a message arrives, we're just going to loop over all the subscribers and send messages to them. So in terms of scalability, this might be a little too simplistic, in which case a full-featured broker is going to be much more robust. It's also not suitable for clustering because if you have multiple application instances, each one is going to know about some portion of the subscriptions, but not all. Other application instances will have to maintain other subsets of subscriptions, whereas with a message broker, each application instance can connect to the message broker, and the message broker understands all of that. It has knowledge of all the subscriptions. So this is an example of the message flow when we use an external message broker. That should give you an understanding of how does it actually fit in. In the bottom right-hand corner, over here, you see the message broker, which is either RabbitMQ or ActiveMQ or some full-featured message broker, which can be in process or out of process, but in any case, it's most likely on localhost or perhaps on a local network. It's something very close by. And we have this Stumpf broker relay. And what the Stumpf broker relay is going to do is, rather than handling the messages, it's going to pass the Stumpf messages on to the message broker over a TCP connection. And then messages coming back from the message broker are going to be sent back down to the response channel, and then they're going to go out back to the client pretty much unmodified. So in this case, essentially, the application becomes a conduit or a kind of gateway between the clients, the browser clients, and the message broker. And if you think about it, that kind of makes a lot of sense from an application standpoint. We're not exposing the message broker directly over the web, which is something that is absolutely possible to do, actually. Both ActiveMQ and RabbitMQ can be reached directly from a browser. But of course, traditionally, that hasn't been done. They're typically behind the firewall. So what this architecture enables is the ability to put the application make the application as the Stumpf broker. That's what browsers see, which is kind of the architecture that we're used to for building web apps. We have the application server responding to browser clients, continues to be that. Except now we also have the ability to delegate messages onto a broker, and that gives us the best of both worlds. We can do things in the application first and then pass them on to the broker when we want to reach subscribers. And what the configuration looks for that? Well, absolutely. First of all, you have to make sure Rabbit is up and running with the Stumpf plugin enabled. Or if you have ActiveMQ, you have to do similar steps, make sure ActiveMQ is up and running. You can even do that from Spring configuration. And once that's the case, then you basically do pretty much the same, except you say in here you configure the Stumpf broker relay with specific destinations, and you definitely want to list the destinations there matching to what the broker supports, because if you unknown destination to the broker, it's going to close the Stumpf connection and send an error frame back. So check the Stumpf broker documentation page. Make sure to understand the destination semantics, which are usually pretty well documented and pretty easy to understand. That will give you a good understanding of what you can do with the message broker. And then any kind of additional features above and beyond Stumpf itself will be listed there as well. So as a result, now our application is actually backed by a real message broker. So before we get into the demo, one last quick subject, which is actually very important, is how to incorporate user information. Authentication. When we are connecting, first of all, Stumpf has a connect frame with authentication headers. And those could be used to provide a username and a password. And that's very convenient when Stumpf is used over TCP. However, in this case, we're using Stumpf over WebSocket, and that means that we have to establish a WebSocket connection, which requires us to use HTTP first, and then to do the HTTP WebSocket handshake. That's kind of how we get into the WebSocket session in the first place, by using an HTTP handshake that then returns a status of 101 and switches to a WebSocket interaction. So based on that, we know that when we use WebSocket, we know that we started out with HTTP, which means that we can use regular HTTP mechanisms for authentication that we already know and use. For example, Spring Security is configured in the sample that I'm going to show. And once we have HTTP authentication, our HTTP servlet request will contain the principal that's authenticated, and that's going to be passed into the WebSocket session. And then all messages that flow through, all the Stumpf messages are going to be enriched with a user header by Spring, which means that you now know exactly who these messages are from, and you can respond accordingly within the application. So one very common thing to do is to access the user information, as you can see in this example. And then you can really do something more meaningful based on that. And also you can respond essentially then with information about who is actually this message coming from. Another common thing to do is reporting errors to an user. You can see an example of the message exception handler annotation here, which is very similar to the Spring MVC exception handler annotation. We're going to handle here exceptions from the controller, and we're going to respond with an error that should be delivered only to the subscriber, to that particular user that sent the message that's being handled that resulted in an exception. Or if we're sending asynchronous results to the user, we can use a simp messaging template. Once again, simp stands for Simple Messaging Protocol. In this case, this trade service is executing a trade, and then when the results are available, probably asynchronously, we're going to want to send the results to the user, but not to anybody else. So you're probably wondering, how does this all work actually? How does send to user work? Well, on the server side, whenever you use this annotation, send to user, we will take that destination and translate it into a destination that starts with /user. And that's a destination supported within Spring, a special Stumpf destination. It is resolved to /q/a plus a unique q suffix that corresponds to that user, and then sent to the broker channel. So that implies that the user already subscribed to this particular queue. And indeed, on the client side, when the client first connects, it's going to have to subscribe to this queue. And the way it knows what the queue suffix should be is by checking the connected frame, which is returned in response to a connect. And that contains a header with the suffix, as well as the current username. So effectively, the client will detect the unique name suffix that it needs to use, which is session specific. Then it will use it to subscribe to a particular queue, and then the server can begin to send information directly to that user from anywhere in the application. And this is the message flow for the full picture. We have messages coming in on the request channel, Stumpf over WebSocket messages. They can be delegated to one of several message handlers, and of course your application can have more message handlers if you want to have additional ones. And further, the application can send messages to the broker channel, which then get delegated to subscribers on the client side. And all of the infrastructure behind this is going to be automatically provided through the Java configuration that I showed earlier. And that Java configuration gives you all of these details without having to know them up front. Now, when you work with user destination, there's going to be a large number of queues because the user is going to create a queue that they need to work with. And that means that you need to worry about removing these queues, which is going to be how exactly you do that depends on the Stumpf broker. So, for example, RabbitMQ, if you use a specific destination like that starts with /exchange/amqdirect, that creates an auto-delete queue. And ActiveMQ has similar config options to purge inactive destinations, so that's something that you have to check with your specific broker. So now we're going to turn our attention to the sample application. I'm going to run the sample in order to show the functionality. And in this case, I'm just going to use Maven JDRun, but I can also run it on Tomcat or Glassfish. And once the application is up and running, I'm going to open a new tab and then get into the application. And let me make this a little bit larger. This is a Spring Security login page. You can see here the username and password that you have to use for this sample. and it's also giving you a pointer to the web security configuration. This is actually using the Spring Security Java configuration that's available in the milestone of Spring Security 3.2. So once we log in, there are actually two versions of the applications that highlight different approaches client side. One of them is a more traditional version, and the other one is based on Kujo.js. It's really a more advanced version of the client side, so you can take a look at both of these. They're functionally absolutely equivalent. So once we log in, you can see here the actual application. It's a stock trading portfolio. It shows various companies in which we hold positions. You can see here stock updates. The prices are changing the whole time, every 1 or 2 seconds. And then that displays updates to the value that the portfolio holds. And also we can initiate a buy for a certain number of shares, and there's a simulated delay so that after a few seconds we should see the quantity increase to 100, and you can see a position update appear at the bottom. We can do this one more time. Buy, we should see it go up to 150. And then another position update appears at the bottom as a notification. Of course, we can take a closer look at this in the network tab of with developer tools. We're going to do that in a moment. And unfortunately, the network tab has very small font, which is very difficult to customize. So what I'm going to do is just copy it over into an editor where we can see in more detail. So let's go ahead and start over so we can see the initial messages. So once we sign in, we're going to see the WebSocket connection down here. And I'm just going to go ahead and copy about 10, 15 of the initial messages and paste them in here so we can take a look. You can see the very first message there is just the letter O. This is something that's part of the SOC-gs protocol, so we can ignore it. It just means that we're ready. The connection is open. Then the next thing we see is a connect frame, which is going from the client to the server. That's the Stumpf connection. It's specifying the accept version. So we're going to communicate with version Stumpf 1.1. And then this is a heartbeat setting. We want to receive a heartbeat every 10 seconds. And if we don't get a heartbeat, basically we're going to assume the server has gone away. Vice versa, the server will do the same for the client. And then the server is going to respond with a connected frame. So this is kind of the initial Stumpf communication. And you can see here that the connected frame essentially confirms the heartbeat settings. Because we're using the simple broker, we're actually not going to have a heartbeat. But the full-featured message broker, of course, will give us that capability. And then we have the user who is logged in, and we also have the unique Q suffix, which the user can use to subscribe to various destinations. And then what follows is a bunch of subscriptions that you can see. The client is subscribing to a variety of things here to receive positions. This is the initial loading of the UI, then to receive stock quotes over time, then to receive position updates as a result of trades, and you can see the unique suffix appended to the end, and also to receive error messages as well. And then we can see some messages here being sent from the server to the client. That's the message Stumpf message command. The first one is just the positions for the portfolio. That's when the UI is loading. And of course, we can do that over HTTP as well. And then the subsequent messages are all stock quote updates, which come very frequently, every 1.5 seconds. And that's what's causing the UI to update. And this is actually a good example of use of WebSockets, where we have a relatively frequent exchange of messages with information being sent down. Quite a few events are coming all the time. Now let's perform a buy. Let's say 199 shares. And then as soon as the buy comes back, we're going to click on WebSocket again in order to see the latest messages. And then if we go to the bottom, we should be able to see the trade message as well as the response. Coming back over here. So this is the trade message. This is where the client sent a message to /app/trade in order to request a buy of 199 shares. And then intermixed with the stock quotes, just a little bit below, we should be able to see right here a position update. You can see this position update, which is coming back now. The total number of shares is 349, and that came back just a couple of seconds later. So now let's go back to the server side and take a look at what's going on there. In the source code, first of all, for our configuration, we are going to use the enable WebSocket message broker annotation. And we're also going to enable scheduling because we want to schedule sending stock quotes every 1 or 2 seconds. And then we're going to do two things. We're going to configure our Stumpf endpoint to be at a /portfolio so that when we connect from the client side, if you see over here, this is the client side. We're going to connect to the web application. Spring WebSocket portfolio is the web application name, and then /portfolio is the URL path at which we're going to receive Stumpf over WebSocket messages. So that's for the endpoint configuration, and then we're going to choose to configure the simple broker with these prefixes, or the application messages will begin with /app. Then we have a portfolio controller, and that is going to receive, first of all, subscriptions for positions. And then depending on who the user is, we're going to return the positions of the portfolio for that user. And this is used when the application loads initially. And also we're going to accept positions. We're going to accept requests for trades. This is when the client wants to perform a buy or a sell. We're going to get that information. And then we're going to delegate to the trade service. And the trade service is a separate component, which is an add service. So it's just a Spring Bean, essentially configured with a portfolio service or a messaging template. And we're going to do a simple execution here and then simulate sending the message asynchronously by putting it on a queue. So that it can be sent a little bit later asynchronously. This is just simulating, not really performing a trade here. And then every 1.5 seconds, we're going to check to see do we have any new trades executed. And if we do, we're going to send a message to that user to position updates. And then we also have a quote service, and the quote service is going to, again, this is an add service, just simple Spring configured component, which will take a messaging template and then wake up every 1.5 seconds and send stock quotes. And these quotes are going to be sent to the message broker that will in turn deliver them to all subscribers. And just to demonstrate here, what we can do, I'm going to switch to using the Stumpf broker relay from the simple broker. And I have an instance of RabbitMQ running on my computer. But before I switch, or let me actually get that going, I'm going to stop the server and then start it again. And while this is starting up, let me show you the client side of things. This is the index.html the actual details of the JavaScript programming model here are not part of this presentation, but I do want to show you how we establish a socket connection. So we do new soc-gs instead of new WebSocket, and after that everything should be very similar. And then we use the Stumpf.js client. We basically run Stumpf over WebSocket, or in this case over soc-gs. And once we have that, then we can use the Stumpf client to subscribe to specific things and then to receive the result in a callback. In this case, we're going to load the positions by parsing the JSON message, or we're going to parse stock quotes and then process them in order to update the UI, or we're going to receive position updates as a result of sending a trade, and we're going to update the position. So you can check all of that in the actual source code for the sample. And now that we're up and running, we should be able to see here starting Stumpf broker relay, initializing TCP connection to the broker. So we're up and running. We're connected to the Stumpf broker. And the functionality should pretty much be the same. I can reload. I have to log in again. And then I can perform a buy, 150 shares. So we go up to 200, or I can sell all of them. And then we're going to be down to 0. So the functionality is pretty much the same, except in this case, the messages are actually flowing through Rabbit MQ as the message broker supporting us in delivering subscriptions. And there's a lot more that I could be going through and explaining this sample, but hopefully this gives you an idea. At this point, I want to stop and allow a chance to receive some questions.
Hey there. Okay, so we have a couple questions queued up. Lanford Wilson asks, why socket versus HTTP layer?
Socket versus HTTP?
Correct.
Right. I'm not sure I fully understand the question, but
yeah, me too.
Let me just
Lanford, if you're still on the if you're still on the line, Lanford, you're welcome to clarify.
Right. So basically, as we know, HTTP runs on top of TCP, and TCP, there's a socket there. So the HTTP protocol is essentially an application-level protocol that we all use. We typically don't write applications to sockets directly. Now, with WebSockets, what we have is the ability to switch to a socket interaction with the client, which gives us the ability to exchange messages, and that is something new in web applications, which gives us new capabilities to have a bidirectional full duplex communication. However, it does mean that we're on the level of a socket, which means that we have a lot of low-level concerns to deal with, which is why we're introducing the use of Stumpf. So you can think of Stumpf as being the application-level protocol versus how we use HTTP for REST interactions.
Thanks, Rossen. Sri Bandari asks, does Stumpf broker relay support application clustering?
Yes, actually, that would be the way to go for application clustering. Essentially, you can imagine multiple application instances running, allowing clients to connect. And each of them is going to connect to a specific Stumpf broker in the backend, I should say a full-featured message broker like Rabbit. And that means that the Rabbit broker is the central authority for all subscriptions, no matter which application it's connecting from. That gives the clients freedom to connect to any application server, and then the relay is going to delegate messages to the message broker, like Rabbit, and then Rabbit is going to effectively respond to the subscription no matter where the client is connected from. So yes, that very much is intended to support multi-application server scenarios.
Thanks, Rossen. Valent asks, is it possible to secure Stumpf resources with Spring Security OAuth 2? I mean that somehow pass the auth token and Spring Framework authenticates the user based on the token, just like a regular REST API.
That should be possible. Yes. First of all, the security authentication, as I mentioned in this example that we looked at, is based on Spring Security, and it's HTTP-based authentication. So how the authentication actually occurs is up to the application, and what kind of authorization tokens are provided is kind of an orthogonal concern to what we're seeing here. You can think of it as what connects the dots is the principal object which is available through the HTTP servlet request, which also gets carried on to the WebSocket session. So whatever authentication and authorization is available with that object, how it got established is orthogonal to what we see here. But once it is established, we can use it within the Stumpf side of things as well.
Excellent. Very important and interesting question from Alex Behrens. Is support for this in Tomcat currently restricted to the RC versions of Tomcat 8 only? And yeah, that was it.
Mm-hmm. So Tomcat 8 is in RC3. It is moving towards a GA version at some point, maybe later this year, at the end of the year. The WebSocket support, which is in Tomcat 8, is going to be ported back to Tomcat 7 very soon. I think that will be Tomcat 7046, maybe, if the release is successful. But it basically indicates the fact that it's going to be backported to Tomcat 7 essentially indicates already the level of stability and the full-featured functionality that's available in Tomcat now. Of course, it's new functionality, and of course, there will be some issues, but the Tomcat team is very actively working on this and very responsive on the mailing lists. And keep in mind that, as I explained at the start of this presentation, all the WebSocket runtimes have new versions re-implemented as a result of JSR 356. That's really the big benefit, in my mind, of JSR 356, is the convergence of all these runtimes to provide WebSocket functionality. So yes, the runtimes are fairly new, but at the same time, lots of people are trying them out and lots of people are testing them. It's getting a lot of attention, and now is really the time to try it with a specific use case, and you will get immediate attention if you report any issues.
And speaking for our own WebSocket implementation, obviously that's still in Spring Framework 4 Milestone 2, so we're sort of in a similar situation, right, in terms of converging and the features that you've been talking about today that go beyond the JSR 352 spec. While you take Spring libraries and embed them in an application, making them independent, I would imagine, of any particular runtime's capabilities, we're kind of in a similar situation, right? In that we're even though we go far beyond the spec, our WebSocket implementations are release candidate as well. So while they're usable today, and independent of Tomcat's implementation or any server's implementation, we're also still kind of tracking things and marching towards a final release.
I mean, to put it in perspective, a year ago, what we had a year ago was we had several servlet containers that had WebSocket functionality that I would consider somewhat experimental in terms of trying to find the right balance of what the API should be, the WebSocket RFC being completed, kind of a lot of things being in flux, having no real solutions for fallback options, etc. A year later, we have JSR 356, we have all WebSocket engines rewritten, but it also means that they're now going to be basically running on these versions for some time to come, rather than expect them to completely switch implementations in a year again. And at the same time, you have frameworks like Spring Framework that provide you further capabilities on top that you actually need in order to run today. So this is very much getting to the point where you can actually start building these kinds of applications, not just researching as it was the case last year. And of course, by the time you actually end up putting something together, as we all know, that doesn't happen in a week or two, you will have final versions of all of these technologies.
So I think this also answers a question from June, who is asking if we can use JBoss instead of Tomcat, and I think the answer is just then, if you're using the Spring Framework 4.0 Milestone 2, or subsequent milestone, if you're using our implementation of WebSocket, that it really runs on any application server, and you're not depending on bits that come from a server provider. So I think
yes,
the answer you just gave does dual duty.
Let me qualify that with a little bit more detail.
Sure thing.
So JBoss, first of all, doesn't have WebSocket support in previous versions. The new version of JBoss server, I believe the name of that, there's a new name. I believe it is Wildfly, if my memory doesn't play a trick on me right now.
Yeah, that's it.
Okay. That version has emerging support, I believe, in a release candidate or milestone. I'm not sure what is the exact version at the moment, but there is a ongoing effort to provide JSR 356 support, and that is brand new. Due to some of the JSR 356 limitations I mentioned earlier, it actually means that that won't work automatically with our Stumpf support. But we plan to make it work as soon as the JBoss implementation advances. So you can expect that probably for the final version, Spring Framework 4. But that said, on the flip side of that is that you can actually take even JBoss 7 today, and you can try this sample application and it will work. And the reason for that is because we have fallback options. To put it in different words, if the server does not support WebSocket transport, as long as it supports Servlet 3.0 async, which JBoss 7 does, it will work by using the fallback options. And that's the beauty of the fallback options. They are not only for the client side, but that's the way it works on the server side as well. So you can actually use even JBoss 7 to try this out today. But in terms of actually using the WebSocket transport for the communication to browsers, we will have that support pretty soon.
Excellent. Thanks again. And I had a couple questions on source code and demo source code. I think you have the link right up on the slides right now. Okay, there you go, and there's the presentation. So, and that was another question from Ollie on where the presentation slides were. So, as always, folks, whenever there are resources associated with presentations and webinars that we give here on our webinar program, when we post the replays on YouTube, we generally try to link in the description of the YouTube video to relevant resources like slides or GitHub repos or what have you. So look for that replay coming in about a week or two at the latest. Often we try to do it within the week if we can. And that you can find out about those replays being published by going to spring.io/video and subscribing to the YouTube channel. Or if you go to spring.io/blog and you subscribe to some of the Atom feeds there, either will get you notifications of the webinar replays and slides and all that good stuff. So I think one last question from Dilip, and then I think we've exhausted the question queue. He asks, how is the performance with lots of clients?
Mm-hmm. Yeah, this is one area in which we will do more work before the final release. We've already done some preliminary testing, and the results are pretty good. It's a bit difficult to quantify because any performance test is going to depend on what the application is actually doing. But basically, if you consider the kind of architecture that this enables, you have a lot of levers and a lot of buttons and knobs that you can push. First of all, we're using WebSocket runtime, which means that it's non-blocking in the way it processes messages, starting from the very bottom. Then we have a messaging architecture enabled within Spring. In the Spring messaging module, we have message channels. There are a couple of message channel implementations that we have at the moment. One is executor-based, which means that it's delegating by in a dedicated thread, and you can configure those thread pools for messages being delegated, Stumpf messages to annotated controller methods. We also have a reactor-based implementation of a message channel, and of course that's based on the Reactor project, for which there was a webinar recently. And furthermore, by plugging in a full-featured message broker, essentially we're delegating the work of delivering messages to subscribers to message broker, and of course message brokers have been doing this for a long time. So we have a pretty good foundation here, and I think kind of a unique approach. I mean, if you really look out there, you will find that this is not the first time that real-time web has been solved or has been kind of dealt with. There are various frameworks out there that have given it, of course, with Comet and Bio and various other efforts, and all of them kind of provide go to varying lengths in those different areas. And I think the fact that we're using a fully featured message broker here is a really unique angle, something that should give a lot of confidence in terms of being able to scale in a clustered environment, in a cloud environment, and also having this event-driven foundation from the start by using Spring Integration Lite for actually building the server-side functionality. And of course, Spring Integration itself is a proven concept for which there's plenty of body of knowledge. So while I don't have any concrete results to give, we have done some preliminary tests, and we think we have a good foundation for building on top.
And I think that exhausts the question queue. Let me just double check. Oh, one or two last ones coming in, actually. Do you have another moment, Rossen?
Yes.
Okay, fantastic. Constantine asks, can we use WebSocket to store big data? And by that he means, 20 billion records. Am I reading that right? Oh my gosh. Yeah, maybe. My gosh, yeah, that's 9 zeros. Okay, yeah, 20 billion records.
Yeah, I guess I'm wondering, does that mean 20 billion messages or a message with 20 billion records in it? With regards to very large messages, WebSocket implementations are actually meant to be able to support something like that by streaming in kind of parts of the message to arrive at a time. But obviously, when you're working with a higher level protocol, you will need the message to arrive so you can work with it, so it can be parsed and understood. So it really depends on having some more detail to understand what you need to do to be able to answer that adequately. But I would say there is some support in WebSocket itself, and for something like that, you have to also consider, does the entire application needs to function in this way, or do you have like some specific cases that maybe dealing with raw WebSocket might be a better way to go for some isolated cases? For the most part, you really don't want to write your application as a raw WebSocket, but if you have some specific cases where you need to do something like that, it may be that you use two different strategies there.
Yep. Constantine, if you're still on the line, you're welcome to follow up with us on Twitter at Spring Central, and maybe we can get into the context a little bit more and help you out. Last question in the queue is from Donna. Other than a stock quote, and this is a good one because I think it speaks to just kind of use cases for WebSocket in general. But Donna's asking, other than doing stock quoting, where else can I use Spring WebSocket in doing real time applications? Like what are some of the broad brushstroke use cases you see, Rossen?
Mm-hmm. Yeah, this is a really great question. Actually, the ability to use a WebSocket is certainly something new and gives us a cool capability, which I think most web developers get very excited about. And that's very understandable because we have all this history of doing real-time web things with HTTP, in some cases stretching it to the limit and in some ways even misusing it. So based on that history, I think it's very cool to have this new capability. But at the same time, it isn't here to replace what we all do. And certainly there are some use cases where it is a better fit than others. The easiest way to understand that is if you think about an application in terms of what's the frequency at which messages are being exchanged between client and server, and what's the speed at which that happens. So, for example, what's the latency that you want to have in the application? So, for example, if you are doing Twitter updates, or if you're doing breaking news updates, or you have an email client that needs to know when new messages arrive, obviously doing infrequent polling requests every 3 minutes or every 4 minutes is absolutely fine to do with what we have today using HTTP polling. But if you have other examples like some kind of collaboration style application where you need to see what the other user is doing in real time, a lot of messages are being exchanged, or if you have usually in the area of trading and finance or gaming, visualization, these are all examples where you have a combination of low latency that you want to see results. It's critical to see results immediately, and also you have a high frequency of messages being exchanged. So there's definitely very specific use cases, and it's conceivable that those use cases will grow over time as applications grapple and figure out how to use WebSocket capabilities. For example, we're now starting to see chat pretty much everywhere, and all websites that have any kind of retail aspect to it are going to have some kind of real-time chat. So these kinds of collaborative live interactions on the web are going to continue to increase. But for the moment, there are definitely very big cases in categories of applications that are going to benefit from it, and others that for whom it's a nice capability, but maybe not the highest priority.
All right, I think that exhausts the questions queue for today. So I just want to say thanks to everyone for your time, your attendance, and the great questions. Again, I mentioned the replay will be available on spring.io/video within 1 to 2 weeks. As I mentioned before, you can subscribe to the YouTube channel if you want to get notified, or you can go to the spring.io/blog and sign up for one of the Atom feeds there and get a notification about the upcoming webinar replay. Also, this audience, you guys will be the first to know that we are very excited. We are going to be having Jürgen Holler speak about modern component design with Spring towards the end of the month. I believe it's on the 24th. So there'll be some registration for that opening very soon. So we look forward to seeing you then. And we've got an exciting webinar lineup for the rest of the 2013 calendar year. So look forward to seeing you again. And thanks again. Rossen, anything you want to say before we sign off?
I just wanted to mention that if you have seen this webinar and you have specific use cases that where this may be useful in your application, it is actually incredibly useful to us for you to give it a try. It is a new module. There's a new programming model, and as such, there are going to be things that we need to evolve over time and provide capabilities. So that nothing replaces actually trying it with a real use case in mind. So from that point of view, if you gave this a try, even if it's not something you're going to put in production tomorrow, that would be extremely helpful to get some of that feedback.
Excellent. Thanks so much. Look forward to seeing you at the next webinar, everyone. And thanks again for your time and attention. Have a fantastic day. Bye-bye.